Welcome everybody. My name is Raquel Thompson. I'm at North Anglia International School, currently working in Year 5. Previously, I was head of maths for a prep school in London for 7 years, and I very much have developed a passion for this subject in the primary sector. Today, we're going to be looking at bar modelling, and as this first slide kind of is indicating, it's kind of like I wanted you to realize how, you know, the most effective way to get the children to understand a new concept, which is bar modeling, is quite new to a lot of teachers and quite new certainly to the parents of the children who you'll be teaching. The best way to do it is to kind of get them to explore, and in order to do that, I think the way I've devised today's session, I've decided that it would be a good idea for us to explore as well, for you to explore with me some of the bar models, some of the ideas that led to bar modeling as well. So let's get started. First of all, let's think about what are the bar modeling basics. So what is a bar model? Well, in effect, a bar model is a pictorial representation or a problem or concept where bars and boxes are used to represent unknown and known quantities. So you might start at the beginning of the children's journey with unknown quantities, and then you might move on to known quantities. We'll get back to some examples in a second. Models are most often used to solve problems with the 4 operations, so addition, subtraction, multiplication, and division. But obviously that includes fractions as well. Ratio comes into it, percentages. When you're in older years, that comes to that into place as well. What else can we say about bar models? There's a video here, Dr. Yip Banhar, who I've actually seen. I've attended one of his many seminars back in the day. I think it was 2015 in London, and he is just the master of Singapore maths. And there's just a little quick YouTube video from the Maths No Problem, who he has helped developed that kind of that scheme of work. And there's a little video there for you to see a bit later. Well, there's no need to watch it now, but he's kind of a reference in terms of Singapore maths and bar modeling in particular. It looks like someone is waiting, so give me 1 second. Here we go. Right, so I guess the first thing we need to think about is what is behind bar models. How does this kind of all start? And it kind of started with Jerome Bruner with his CPA approach. So the concrete, starting with manipulatives, which we talked about in the last session, following on to the pictorial representation of those manipulatives, and then moving on to the abstract representation, this time with symbols and numbers to represent what either the concrete materials were trying to indicate, or the pictorial was trying to represent. This picture here that you can see on the right is taken from Maths No Problem. It kind of shows like a variety of things that and how you can start moving on from manipulatives or concrete onto pictorial, and then onto abstract. So going from the actual physical apples or pears, going into counters, for example, as a picture, as a more of not still concrete, but not the real object. So kind of like for like, and then moving on to pictorial representation using bar models, and following that on with the abstract representation using equations. This was back in '66, and you know, once upon a time, Singapore they weren't doing so well in their maths results, and they kind of they got together. It was very, very much collaborative, and they got together and decided to kind of use this method, this concrete pictorial abstract, in terms of a means to scaffold the learning. And you know, many years later, they are one of the leading countries in terms of mathematics learning across all ages. What else could we say? Some things before you introduce. These were kind of taken from this article that I've put at the top here, So if you are interested in reading the article, feel free to do that at the end or at another time. I think someone's got their microphone on. Could I ask you to mute, please? Or I'll mute it now. There we go, because it's interfering. So some mistakes to avoid, and they are, you know, before you introduce bar modeling in your school, and I don't know how advanced that is, you have this in your own schools. One thing that you could do is make sure that the CPA approach is fully embedded. So if it's not yet, if you don't have a culture of concrete, pictorial, abstract approach, then it's probably not a good idea to introduce bar models at this stage. There's a lot of legwork to do before you do that. Another thing that you will see is that this is an example taken from a CPD session that was not done by me, but it is just so you can see how different teachers asked the same question, represented the same thing using different ways, and there isn't really a right way or a better way or a right way or wrong way. There is a way that you should use as consistently throughout the school, and that has to be agreed before teachers go on to teaching the bar models, because if one teacher teaches in one way and then next year or another teacher teaches a different way, that creates confusion, and that's when bar modeling becomes a little bit of even more of a question mark than it is at the moment. Another thing to look out for is that make sure that the basic models are taught before you move on to the harder ones, and we will go through this progression today. Often, you know, you might want to introduce bar models in year 5 or year 6, and you think, oh, you know, these problems are very hard. Let's go for it. Let's just introduce the comparison model. But actually, that's not the right way to go about it. You need to really start with the basic models, which I will explain in a second, in order for the children to really understand, embed those first, and then move on. Even if that takes, you know, anything new takes time to embed, anything new requires time to develop. And if it takes a bit longer and a couple more lessons than you expected, then I think it's time well invested, because it will pay off in terms of the way that the children will understand and use bar models to solve harder problems. Another thing is obviously the experience that teachers and children may have. So not everybody has the same experience. Some children may have seen it before, some children may not have seen it before. And it's important to actually give the chance for bar modeling to be used. You know, often we are introduced to these things, and then you get to the classroom and it's so new and it's so often so alien. It was very alien to me when I first got introduced to it, and you get scared, and, you know, in the spur of the moment, you just carry on how you just, in the way that you usually do. However, it's important just to, you know, to have that in mind, that yes, have a bit of experience first. Make sure you have good ground basics as a teacher, that you understand how bar modeling works. But then don't be afraid of putting it into your lessons and just trialing it out. So long as you know how the bar modeling system works, trialing and making mistakes here and there is not going to confuse the children, for sure. And the children will also learn that in bar modeling, they will need practice as well. It's not a case that they will get it first thing. They will need quite a lot of practice. And the last thing, questioning. So questioning the children to edge their thinking forward, so that by the end of the question, they feel that they're the ones that solve the problem. So, you know, if you are really aware of how you want the bar model to work, and how you want them to represent it, you kind of, then you can tailor the questioning so that the children go, oh yes, I could do this. But, you know, in a way, you've guided them through that process, but they don't really realize that. So these are some of the mistakes kind of to avoid, or things to look out for before introducing. And now let's just go very quickly to go through the types of bar models that there are. There are 2 types. The first one is the part-whole model. That's the basic one. And it's often called part-whole, mainly because you might have 1, 2, 3 parts and then a bar at the top. that includes, that represents the whole. So if it's 2 parts, you can call it part whole. If it's got more parts, you might call it part whole. Anyway, we would be here forever, so you just call it part whole models, okay? But in effect, the main thing is that the whole bar at the top represents the same length as however many bars there are underneath. These ones we tend to use. Let me just go through this so I don't forget any bits. So it's a simple pictorial representation, and it kind of helps the children to see the relationships between the numbers. So we will do some examples in a second. Sometimes there's a horizontal bar. In the example that I'm showing you here, I'm just using an arrow, but you should start in the early years, you should start with a bar that represents the total, the whole, and then underneath the parts. And if you have a smaller number, for example, a 3 and a 5, then the 3 will take up a smaller bar, and the 5 will take a larger bar. If they are equal parts, you make sure that those equal parts are represented using the squares on the paper, that the children are actually using the same number of squares to represent those equal parts. And obviously this part whole model, it can be used for all operations and including fractions and missing numbers. There's a link there for you to have a look at. Some good ideas there on how to use part whole models in the classroom. It's from Maths No Problem as well. Feel free to do that after the session when we're finished. The next one is a comparison model, and this is more, I suppose, the one you might use more often from year 3 onwards, because it kind of allows you to see, to compare two quantities. It's easier to compare the relative size of different parts. So yes, you will start with the basic part whole model, but then you will notice, and we will do some examples today where you will notice that you will start having the need to move on to the comparison model at some point. Comparison model, the difference is that the bars are not aligned side by side, they're on top of each other, and you can see the difference between those bars very clearly, and you label them as such. And then the other difference is that the total is not now at the top, but it's on the side to represent the total of all of the bars. So also, this is very useful for all operations again, but this time we can add also algebra and percentages and ratio. Right, so I think it's time to show you an example, and we'll start with addition. I will tell you that most of the ideas that I have here today, that I'm presenting to you today or sharing with you, have been taken or have been inspired by a course that I did with White Rose Maths over the summer. If you are interested in bar models, I would definitely suggest you taking that on. It's £10. It's done online, and it's also it's done online, so it's done in your own time, and it's quite comprehensive. It's really good. It goes all the way through all the steps. It's got 3 series, and I would definitely recommend, if you're interested in just getting, because this is just a short webinar, it may not be enough. So if you're interested in getting a bit more of an insight or more CPD even, do that. I have no affiliation with White Rose Maths. I just happen to have found that course particularly good. So for addition, for example, if I said that Mary had 5 sweets and John had 3 sweets, how many sweets did they have together? Now this is a typical example where you would start with some sweets on the table. Obviously I didn't have sweets there, these are pictures, but I would have sweets on the table, and you try to align them as well. Encourage the children to align them on the table so that they can see the line, so that we can then move on to aligning them, aligning counters or any other manipulatives still in a line. Apologies, there's someone else coming in. Hold on a second. Okay, so we move on from the manipulatives all the way to the real life sweets, all the way to manipulatives that represent those sweets. In this case, Mary's sweets are green and John's sweets are red counters, and always alongside the calculation next to it. And then moving on to the bar model. And you will see that the bar model also represents all the boxes. If Mary has 5 sweets, I have 5 boxes, and John has 3 sweets. It's got 3 boxes. Now, this is what we call a discrete model, and it's called discrete because you can see every single part in this model, so every single unit in this model. And the way that we're doing addition in this case is called aggregation. So you kind of aggregate, you add them together. Someone has something, another person has something else, let's put them together. That's called aggregation. And this is the type of model is called discrete. But there is also a type of mixed model where I can have a bit of discrete, a part of a discrete model, but a continuous model to start off. And that kind of helps with number lines, for example. So this is called mixed because I have a continuous model for Mary, because Mary has 5 sweets, for example, and I would like to add on 3 sweets from John, and John gave her 3 sweets to Mary. So this would, in fact, representing the bar model in this way would actually change the word problem that you were given to start. So at the start you had Mary and John. Mary has her own 5 sweets and John has his own 3 sweets. For this bar model, you're saying that for augmentation, that is, you're saying that Mary has an amount of sweets, in this case is 5, and you're using continuous model because you know it's a 5. You don't really need to split it into 5 parts. And then you could say that John gave her 3 more, and that's when she augments, so she increases the amount that she has. So that makes it's just so you can so you are aware of how representing a bar in a different way might have an impact on the word problem, or vice versa, on how the word problem might have an impact on the way that you represent the bar model. Some examples now on subtraction. Please let me know if I'm going too fast. Do stop me. I'm happy to kind of explain as we go along. But I have prepared some examples for us to work together in a minute. So my idea is to go through addition, subtraction, multiplication, division, and then one example together, and then you're going to go off and do a few things together, but without my help, so much help. So, but do let me know. I have the chat here and I can kind of see if you need anything. Right, moving on to subtraction. So there's 3 types of subtraction models, so to speak. One is kind of a reduction. So you start with an amount or an amount is given and you reduce that amount. For example, Mary had 8 sweets to begin with. She then ate 3. How many sweets did she have left? And you might represent it like this, in a way that Mary had the 8 sweets is represented at the top with a bracket. Some people would represent it with the bar. In this case, I prefer a bracket. And what I've done here is that I've represented the 3 sweets first, and I've used the 3 bars and I've crossed it out. And the reason I crossed it out and not rub out the boxes is because I want to show that I have eaten them. She started with 8, so those boxes cannot be rubbed out, otherwise that would represent 5. So she started with 8, but I can write that is a 3. I could have used the continuous model here if I wanted to, but it started with 3, and I crossed it out to show in my model that I started with 8 and I took away 3 from that 8 to have 5 left over. Okay, so that is the reduction model. Then we have a partitioning model where Mary had 8 sweets. She had 3 red sweets, the rest were green. How many were green? So your model might look like, obviously you were given the total, so that's your total at the top. You are also given the red sweets, and you are not given the amount of green sweets. Obviously always get the children used to labeling each part. It's very important to have that done, and to continue to, alongside the bar model, always have the calculation, just to get them, by the time they get to the abstract side of things, it won't be alien, it will be easy for them to see. But this one, we're not crossing out. And why are we not crossing out? Because she still has green and red sweets. She didn't give them away, she still has them, in this case, we were just looking out, we're trying to find out which ones were, how many she had that were green, but she still has them all, so we can't cross that out in this case. So that's the partitioning method. And then we have the difference method, which is kind of more in line with a number line, for example. So for Mary has 8 sweets, John has 3. How many more sweets does Mary have than John? And this is where you will find that this model perhaps is not going to work, because you have 8 sweets for Mary, you have 3 sweets for John. How are you going to show that difference? So this is where you want to now introduce your comparison model. So you can see, I hope you can see the difference, how this model doesn't really work to show or to help me work out the problem. But this one, I can clearly see that Mary had 8. That's a longer bar than 3, than John's 3. And I can draw an arrow here with a question mark. And then I can just work out that is 8, take away 3 equals the 5 there. So that's subtraction. Moving on to multiplication and division. An example could be sharing. So Mary has 40 sweets. She wants to share them equally between 5 bags. How many sweets will she pack in each bag? So in this case, you obviously know the total again. The total is represented at the top. And because we're doing sharing, multiplication, division involves equal parts, but we don't actually know how much in each part, how much each part represents. What we do know is that we have 5 parts. And so we divide 40 by 5 and the answer will be 8. And so the question mark now represents 8. But this is sharing. We can also do grouping. Similar kind of problem. Mary still has 40 sweets and she wants to have bags with 5 sweets. So this time I am given how much each bag has got inside it. How many bags will she need? But I don't know, and I've got the dotted lines here. I don't know how many bags I will need. In order to find that out, I divide the 40 by 5, and I'm going to find out how many 5s fit in 40, and that is 8. Lastly, on this topic of multiplication and division, we're going to talk about fractions. So for example, if Mary has 40 sweets again, she eats 3/5 of them. How many sweets does she eat? So obviously 40 is going to be, again, our total. Fifths, you would not introduce this unless you had already introduced fractions, of course, but they would be able to recognize the 5 in fifths and be able to realize that you have 5 parts. And so they would draw a bar with 5 parts, represent the total at the top, and then find 1/5 of 40 by working out 40 divided by 5 pieces and working out that's 8, and then 8 times 3 or 3 times 8, 3 lots of 8 equals 24, and then answering the question in words. Next, so those were the basic models, part-whole model, and we're now going to move on to the comparison model, which I kind of showed you earlier with the subtraction. Are there any questions at this point before I continue? No? Yes? Okay, hold on. You're unsure that the bar model adds anything for grouping. Let's move back. Oh, sorry, hold on. It doesn't add in this case, perhaps. I think that's a valid point. It's just to show how you can use it for grouping. Obviously, in a problem like this, it's an example, isn't it, to identify what it is. Let me see. In order to draw the bar, I need to find the answer. If I know the answer, why would I draw the bar? Well, the idea is that I think the questions that you're asking there are the questions that a high ability child would ask, and you are absolutely right. For the numbers that I gave you there, absolutely no need to do that. But you will find, hopefully, in the next few examples, when the comparison models come in, you will find that there is a need for bars, because you will not be able to calculate straight away, and the bars will help you to actually figure out which calculation. But of course, if the children can already do the bar model, find out what the calculation is, fair enough, they perhaps don't need it. But if you don't train them to use bar models in simple examples, then perhaps they won't be able to access the harder models when the time comes to use them. I hope that makes sense. Right, so comparison model. Let's have a look at this one. This is going to be one that I'm going to a worked example from me, and then I'm going to share a link with you after, and you're going to have the opportunity to play around with using bar models. Hopefully, anyway, I'll come back to that. So in a cafe, a muffin costs 2/5 of the cost of a coffee, and the cost of 3 muffins and 2 cups of coffee is £9.12. How much does a cup of coffee and a muffin cost? Now, the first thing that I would draw the attention to the children is the fact that I have a fraction here, and the fraction has a 5 as my denominator. So I would I would train them to look out for key things, key elements in word problems such as this one, whereby it gives you a hint as to how big that, how large or how long our bar might be. So for example, if I have 2/5, then obviously coffee, hold on, sorry. I realize I can't, what you can't see when I use my, I need to look at that side. When so if I have 2/5, then I'm going to represent a muffin and the coffee. I'm going to represent it in fifths, okay? So 2/5 is a muffin costs 2/5 of a coffee, which means that the coffee is 5/5 and the muffin is 2, okay? Then I need to find out what the cost of 3 muffins and 2 cups of coffee. Well, I know what the cost is, but on this particular point is you want to train the children to find patterns. So in this case, could I use the coffee, the 5 units of the coffee twice? And could I use the 2 units for muffins 3 times? So I'm going to show you what that would look like this. So hopefully you can see that I've got 1 cup of coffee here and another cup of coffee there. And then I've got 1, 2, and 3 muffins. And altogether, they cost £9.12. Now, hopefully you will realize, you can see that why this bar model is useful here. And the reason is that you can see each individual box. They are all equal parts. And so now the next thing you can do is just to calculate 9.12 divided by the number of boxes. Obviously, try to change that 9.12 divided, making it 912p, I guess, would be easier for the children to work. 912 divided by 16, if they know how to do it or divide by 2-digit numbers, then they can do it as a calculation. Otherwise, when you're trying to use the bar model, the calculation is not the main thing. It's to show how to get to the answer to the problem. So in this case, if I'm doing a question like this in year 5 and the child doesn't really know how to divide by 16, I would just give it a calculator. I'll just say, oh, divide by 50, that's 57. So long as they've showed me at that stage that they know the process, they know how to get to the answer. And then of course, 57 represents each bar, each box, each part. And so all I need to do is 57 times 7 squares. That represents 1 muffin and one muffin and 1 coffee, and that would give you the total cost. So 1 coffee and 1 muffin would cost £3.99. Hopefully that made sense. Okay, so this is the time for you to play, and I'm going to share now a link that I have. So bear with. Oh, the link is up here, but I'm going to put it on the chat. So bear with me. You can watch my little. Right, a second. I don't know if you have used this app or this thing called Miro. So if you could access it, you should see, and I will put it up here. Don't feel self-conscious because I can see. I don't know who is going to work on what. Hopefully you will see a screen like this. I'm hoping that you can see my screen. Please let me know if you can't, now that I've changed. I am sharing a screen, yeah. Okay, so let me know if you can see this, because this obviously the ideal scenario would be we're all in a classroom and we can all kind of share and practice on paper. But I thought I could put this together and see if we can do an example together online. Let me know if you can, on the chat, please, if you can access this. Yep, you can see it. Perfect. Thank you so much. The way this works, if you pinch, I don't know which device you're using, but you can zoom in and out. We're going to start with example 1. So if you can't see it straight away, just have a look at the 3. I'm on 3% here. This is huge, this screen, but I've put it on just one section. We're going to start with this one. And what I've done is I've decided, I've kind of given you, each of you, a section. Okay, so each person can kind of work it out on a section. You can use the pen if you would like, so you can draw bars using the pen, although this one is not very well drawn. Or you can use smart drawing as well, in which case I believe it turns it into straight lines. Let me have a look. Oh, no, not quite. I think probably the best way to start is probably using bars. But if you zoom in, you can actually see the little squares. So you can do it like this, or you can do one like that, and then just copy and paste if you want a discrete model, or just drag it out if you want a continuous model like that. Okay. Does anyone have any questions before I just read the actual question that you're working on? Does anyone have any questions about this or how to use this? If you prefer to use paper, that's absolutely fine. I just thought it'd be nice. Last time I felt like it was just me talking, and this time it'd be nicer if you do it with me. Right, I don't see anyone particularly complaining on the chat, so I think we'll start. So on example 1, it's the easiest one of the 3 that we're going to work on today. It says a baker bakes some cakes over 3 days. Now you will see I gave you some help. I already wrote day 1, 2, and 3. Each day he makes 12 more cakes than the previous day. In total, over the 3 days, he bakes 243 cakes. How many cakes does he bake on day 2? So what I'd like for now is like spend 5 minutes, and you can see each other's work as well, but just grab one section here and try to spend 5 minutes, try to represent, not so much work it out, but represent the bar model, this problem using a bar model. And let me know if you need any help. I can guide you through as you go along. It'd be lovely to see people working here. I can see the screen, see if anyone is. I won't know who you are, but I will be able to see what you're doing. I can't see at the moment. Is anyone working on it? I can't really see anything happening. Absolutely, yeah, sure, no problem at all. Let me put that here. Oh, right. Copy and paste. There you go. If you are not so keen on doing it on Miro, that's absolutely fine. Just try to work on a piece of paper. That's absolutely fine as well. And we can compare notes in a minute. So let's say at 5:15, we can get back together. Can't see a link. Oh. You can't see the link on the chat. Oh, I see. Hold on. Everyone, here we go. I think I know what I've done wrong. Can you see it now? Perfect. Thank you. No wonder no one was there. I think I only sent it to one person instead of everyone. Oh, well. Ah, great. Now I can see some action, some movement on the. So make sure you are on the example 1. There's 3 examples on that page. Make sure you're on example 1, Tuesday, 5th of November. And I'll explain where where I took them from as well. Oh, excellent. I can see some of you already starting. Thank you so much. If you need help, please let me know, okay? Oh, someone's just moved I'm just going to move the board over, okay? Someone's moved it by accident, that's all right. This happens with the children in the class as well. I don't know how they do that. Oh, how do you do that? Hold on. Oh, hold on. Please don't type anything at the moment. Let me just move it back to its place. There we go. Let me lock it. Okay. I'm looking to the side because that's where my big screen is. So I guess on this first question, what you might do is obviously have day 1, 2, and 3. And we look for things that are that are the same. So you're going to try and draw a bar model that shows something that is the same, ideally, along the 3 days, and then show what is different in the next, on the other days. So if a baker makes cakes over 3 days, each day he makes 12 more cakes than the previous. In total of the 3 days he bakes. Yeah, I can see great work, guest designer up there. Got 3 bars going on. Great. Just be careful with the sizing of those extra bars. I would make them slightly smaller because otherwise it might make it seem like it's the same amount and we don't know exactly the amount. So the extra 12, I would make that bar slightly smaller. Interesting. And this is really interesting because it kind of gives us, I find it fascinating because the children will do exactly this. They will all have their own different systems, their own different methods. And it's quite nice to then unpick which ones work best, which ones work not so well. Okay, just 3 more minutes, or 2 more minutes in fact. And then we'll just work on the next thing. Okay, so I've got this model here at the top that I'm pointing at the moment. What I would say is that it's missing a total that is not represented. So it's not yet representing the bar model that we've got. So I would add that in a bracket, for example, and it's not yet representing the 12 more cakes need to be represented every time you've added those 12. So that would be an improvement I would put there. Great. And well done. I would have definitely have resized those 12s as well. So well done. Great to see some of you are doing actually drawing, and I suspect some of you are doing it on paper as well. Just under 1 minute, and then I will show you how I would have done it. And some of you have got a similar idea to mine. Great. Whilst I'm waiting, just make sure you keep that link up because we will come back to it in not very long, very shortly. Just a few more seconds so we can get to 5:15. That's looking good. And I think what I'll do now is I will share my presentation again, and then this will come off in a second. But I really like, oh, there's this bar model here. I'm interested, actually, I might wait a little bit to see where that bar model is going. It's an interesting one. Oh, I see. Yeah. So fantastic. So you're kind of bar modeling after having written this one. That's great. Okay. So if I could have your focus now on the problem, I will share. I don't know how to get rid of this thing. Here we go. I will share my screen now again. So that was the problem that you had. Hopefully you will have realized that in each day, I used 2 bars. It doesn't need to be 2. You can do however you want. The reason I used two boxes was because I knew I wanted to add an extra. And so I needed at least a box to add that extra. So that was the reasoning. But there is no like right or wrong in terms of sizing for this particular problem. So you have day 1, 2, and 3 will have something that is similar on both on all 3 days, but obviously day 2 has 1 extra 12, day 3 has 1 extra 24, so 2 12s extra, and the total is 234. And so hopefully by the time the children have put this into a bar model, then they are able to calculate and to find the answer to the question. Do you have any questions about this particular one? Anything that you've perhaps drawn differently and you would like to, you don't understand why yours doesn't work, or if not, I just move on because we've got 2 more and the last one is particularly hard. Nope, right, in that case, we'll move on. So the next example, which is there already, is this. Charlie has 4 times as much money as Jess, and as much money is the really key part of this problem. Flip has 35 more than Jess, so that language, as much and more, they are different types of adding on, and they have 155 in total. How much money does Flip have? So again, your turn to play. Let's move on to the right of that screen. The bar model is here. It's example 2. Could you just go on to where, yeah, that's it, guest designer. I've got, who else is there? This guest and guest builder. Can you come up to the right? So just scroll to the right and you will find it. And off you go. Again, on paper is perfectly fine as well. What I'm interested to see with a problem like this with the children is, can they understand this language of 4 times as much and the language of 35 pounds more, and how they are going to represent that accurately on their bar model. And because if they don't represent it accurately, then that bar model is not going to be helpful to answer the question. So let's say we have, I am aware that the webinar ends at 5:30. I'm happy to continue after this. So yeah, we'll just continue until it's finished. But I have this example and another one after that. So some of you clearly probably have used this, this type of platform before, or IT platform before. But make sure you are, if you're not using this platform, absolutely no problem at all. Just if you want to like engage and you want to share how you drew yours, please feel free to let us know. Even you could even do what the kids do in Zoom lessons, just show it on the screen if you want, up to you. Oh, this is not what I wanted to do. I apologize. There we go. Now, great to see some of you already working on the calculation as well. Now you have your bar model, you can start using it to work out the answer to the question, which is how much money does Flip have? Great, well, another, let's say 2 more minutes so that we have time to move on to the hard one. Just looking at Tazreen, I would encourage problems like this where there is comparison of amounts. I would encourage a comparison model to be used. Yours looks fine, but just for the children, I think they were, and because of subsequent harder problems, I think if you train them for problems like this where it involves multiplication or comparison of quantities, I would definitely use a comparison model or try to use as much as possible a comparison model. Just a suggestion, I think, you know, I have done a lot of trial and error in my time. You're welcome. Great. I think we will move on to the next one. So because I feel like you need to have way more time than this one for the next one. But hopefully as you were working and I was looking at your work, I've been commenting and hopefully that has been helpful. I'm going to share my other screen back again so that you can see how the work has been, how I would have done it. So I could see that some of you represented the 35, for example, with the bar, which is absolutely fine so long as the bar is of different size to the other ones that are equal. So make sure that like the children really understand that there will always be in problems like this something that is equal, and that has to be represented with the same sized box. Sometimes it matters the size of the box, sometimes it doesn't matter, but what it does mean is that if you are representing that 35, I would have made it smaller. I don't know how much each of these are, but bearing in mind that the total is 155, it can't be much more than 35. So I would put it halfway or less than halfway, or just around about halfway, okay, or a bit more. So obviously, for this kind of problem, the children need to understand that 4 times as much means 4 boxes, not 4 more boxes. That's really key for a problem like this. And £35 more, in fact, includes an extra, either a bracket or an extra box. Once they have this, they have to realize that, oh, these are all the same. What can I get rid of in order for me to then be able to divide the amount that I have by the boxes that I have that are equal in amount. So 155, take away the 35 equals 120, and then divide it by the 6 boxes, and you find yourself that each box is worth 20. So Flip is 20 plus 35. So Flip has £55. Now the hard one, and I hope that you can help each other out. Perhaps feel free to chat. I say the hard one because this actually involves kind of 2 bar models. So you start with one, and you may have to migrate into a different version after. Okay, or use the same one. But anyway, I'll come back to that. So Peter, Ned, and Morris have some apples. We don't know how many. We do know they're there. Now Ned has 2 1/3 as many apples as Peter. I can see here we're working with thirds, so something there in terms of the sizing of the box is going to help me. Morris has half as many apples as Ned, and in total they have 999. I want to know how many apples does each person have. So going back to the Miro, if you scroll down and to the left under the first example, you will find the challenge question. Find yourself a space on that screen and have a go. I might give you a hint in a minute. But I want to see, or you could give each other hints on the chat as well, as if you were, you know, the children in the class. When you're learning about bar modeling, it's very much a collaborative type of work, especially when you're getting to grips with it. So use each other. I can't see everybody yet on that one. I should be down here. So perhaps, I don't know if you need any suggestion. I would, with the children, definitely let them get on with it. Try, even if they get it wrong. The children need to, you know, to be presented with achievable challenges. Obviously, don't present any of this stuff, any of these examples, if the children haven't had the chance to work with fractions and really understand what a mixed number is, and haven't had the chance to work with simple bar models. So make sure that you've done it like slowly, ease them into a problem like this. Whilst you're trying to do that, I can tell you these problems are all taken from Barvember. It's part of the White Rose Maths scheme of work, which in November, which is coming up, so next month, they release problems every day. Levels 1 to 4, they release the answers as well straight away for the teachers to kind of know the answers and help out in class. But the challenge, they do not straight away, and they actually encourage people to post the answers on Twitter. But there are some very kind people who've made lovely videos explaining how to answer the really tough questions, which are completely baffling to the majority of us. Lovely. I can see comparison models are definitely the way forward here. And of course, having read the problem, Peter is going to be the one with less. And so if Ned has 2 1/3 as many apples as Peter, I would suggest, like the example here at the top, that there are 3 boxes in there. And it's important actually in this case to have those 3 boxes, because you will be needing to split them in a minute, perhaps. Don't forget to add the total on the side, to label the parts that you know within that model, any bits that you know. And I would have a look, the key will be to have a look at those 6ths that I can see that Morris has. So Morris has a half as many apples as Ned. So Morris has, if Ned has 2 1/3, Morris has 1 and then a half of a third, which will be 1/6. And then the idea is, can you think of how you can turn all of those parts into something that is the same throughout? So you can change all of those parts into, we shall see. I think some of you have already got the gist of it. Yeah, that's great, Taz. Yeah, that's it. Fantastic, really good. And then, so by doing that comparison model, you are now, the children are now aware of the, I know it's a bit fiddly to work on this thing, on paper it's probably easier, but the children are now aware of all the equal parts, and that hopefully, obviously, in order to do a problem like this, make sure that they already know what a half of a third is. They really, really have that concept of fractions clear, so that they can access the problem. Otherwise it's impossible, and just by reading will put them off. And so, yep, I can see some of you already answering some of the question. So Ned, Peter, we have an answer for Peter, and Ned, and Morris. Right, it is now 5:30. I'm very happy to continue. It's always a pleasure to continue chatting about maths, but if you need to go, feel free. This is still being recorded. If you would like to continue for another 10-15 minutes, do stay on. There's only a couple of more slides to go through just to give you some ideas where to get more information and so on, okay? I think we will stop the examples there. I'm happy to leave that. You've got the problem there. It's shared. You can use that link as much as you want. I'm not going to use it after this webinar, but I'm now going to share the screen again, so you can see what mine looks like, and you will see that it looks very much like most of yours that I've seen on the screen. So I started very much like most of you, realizing that we're dealing with thirds. So I've done this. Ned has 1, 2, and a third, and then Morris has a half of that. So it's 1 and a half of a third, which is a sixth. And then halving all of them shows me that I have lots of sixths, and I can divide them all by 27. So there's 27 sixths in total, and then I could just work out how much each person, how many apples each person has. And then obviously it's also important to make sure that they check the answers, that, you know, don't just get to the answer. Does it work? Do my numbers work out in a way that it adds up to 999? And they will find out that yes, it does. Now, for some of you earlier, I think it was Louise was asking some questions that I know high achievers will ask. And how do we encourage them? You know, they know how to do it. They've got it in their head already. Why are they working out using bar models? Well, we've got a trick to encourage them to use it. And one of them is goal-free problems. And what that is a way to removing the question. So if I had the question, one of the questions that we had earlier, if I actually remove the question, they won't know what the calculation, what is it that they need to do. So they will be forced to calculate, to represent the bar model. And they will be forced not to calculate it in their heads, and they will be forced to just represent the facts that are given. And that is a way to kind of get them to do it. And then you can ask, what could my question be? That is a way to encourage them. If they feel like some of the high achievers feel, oh, this is beneath me, I'm too good at maths for this, then, you know, this is a way of extending. Just flip the question to them. Represent this first, and then tell me what question you could ask, because there could be a lot of questions that could be asked with this particular bar model. How many more does someone have? How many less? Or you know, there's a variety of questions, and you could see they can extend themselves depending on the type of question that they ask as well. Another way to do it is this bar Vember that I mentioned earlier. Bar Vember comes up. They have, I think, 3 years worth now of word problems that involve bar models. Most of them with answers online on this link that I'm showing you here. But a lot of them, the challenge questions, do not have the answers. And please don't make some of the mistakes that I've made in the past. Do not assign a challenge before you've actually done it yourself, before you've checked that actually they are able to do it because you've taught the skills beforehand. There are some questions that seem easy, but the way the questions have been asked, or the way the bar models are supposed to be drawn, are actually quite hard. So I would definitely double check the questions and look out for the answers if you can't work them out. Because actually, I don't think there's any harm in finding the answers online whilst you're learning, because you try first, you challenge yourself, you try once, you try twice, and you go and check. Oh, okay. And then you see, this is how that person has done. This is how to get to the answer. And you go, okay, so next time I see a problem that is similar to this one, I know to represent the bars in this way. I know to, to find a half of a third, for example. And by practicing lots, you will get really much better at representing, or the children will as well, much better at representing problems in using bars. The work dances that I was talking about can be found on YouTube. I've sent you a link there, so to make it easier for you to do that if you're interested in the challenges. Some useful resources online, especially for starting. There's an app called, or a website called Thinking Blocks. They kind of looks like this, and the children have to label, the information is given on the side, and the children have to label the bars, and depending on what the word problem says, they have to drag the right numbers to the correct places. It's actually really good practice. You can use it. It can be used on Macs, iPads, phones. I think phones works as well. But definitely Android tablets works as well. And it's really actually quite good fun for them to practice. It's got addition and subtraction, multiplication and division, fractions, ratio. So it's actually really good. The other thing we talked about last time, it's MathSpot, in order to make the bars but that's more a teaching tool in this case, in order to make like bars for bar models for your presentations. You can use that website is quite good for doing that too. Just to end, how might you try bar modeling tomorrow? Well, a few things to kind of think about before you do that if you haven't yet. Does your school already promote a CPA approach, and is that kind of supported by not only the teachers, then are there teachers that are enthusiastic in the school, or is it supported also by your school leadership team? Does your school have the necessary concrete materials, the manipulatives that we spoke about last time, to promote and embed this CPA approach? Because if they aren't there, then there's no point yet starting with this. It really all is linked, and you need to kind of start from the beginning. Do you and other teachers need more CPD? I would, as I said at the start, I would absolutely recommend the White Rose Maths course. It will be on the next page. I'll show you in a second. But you could have also maths champions within year groups. So you ask one person per year group to be, to actually take the CPD, and then spread the information, the knowledge onto the rest of the team. And that will show, that I think that would be a great approach to starting something like this. Another thing, do you and other teachers in the school feel confident in using the part-whole models to represent the simple problems? So if you're not confident yet, don't present it yet to the children. Do make yourself aware of them and be confident in using them, and then you can show them to the children. You can start by using topics such as addition and subtraction to begin the bar modeling journey through word problems. And you can also give them a model, and the children can make up a story for it. So, I could give you the model already drawn, and you could say a simple one, and you could say with all the labels and all the numbers, and you could say what could be the problem that this is trying to represent. So that works actually for younger children as well. You just say if they know how the bar models work. So something that I've done before, and it's quite fun because they come up with really fun stories about it. And then that's it from me. If you're interested in learning a bit more, the courses are there. As I said, it's £10 for these courses at the moment. I don't know if that's going to be the same forever. They have others online. The Maths No Problem YouTube channel is also a great source of information, and the Third Space Learning is a website that has quite a lot of information, and often they send some good resources for free if you register online. So those are some good ports of call for bar modeling, to look out for bar modeling. And that's it from me. Do you have any questions? I hope you've enjoyed it, and please let me know if you have any questions. Oh, thank you so much, Shar. That's very kind. Oh, thank you. It is actually my absolute pleasure. I love maths. I cannot tell you how much I do. So if ever you need anything, do feel free to email me as well. Okay. Thank you very much. Have a good day if you're in the UK, and a good evening if you're in Hong Kong and Australia, I'm guessing.